Hi, I'm just making this video in response to a Reddit user who's asked a question about Maclaurin series, and I will work through the question, and hopefully that will help. And you can reply in the comments if you have any further questions. So the first part of the question that this student asked was determine the first 6 terms of the Maclaurin series for e to the 0.05x, correct to 8 significant figures, which is quite a lot. And so without going into too much detail about the Maclaurin series, and I don't know what exam board you're on, but in many exam boards, you are given this as the Maclaurin series in the formula book. So you don't need to remember that. You can use this to work it out. And in the formula book that I'm looking at, which is for Edexcel, they actually give you the particular expansion of e to the x in the Maclaurin series. So the only slight modification we need is that the power of x here is 0.05x. Sorry, the power is 0.05x rather than just x. But we can modify that quite easily by just literally replacing everywhere that the x appears with 0.05x. So that would be 0.05x squared over 2 factorial. The next would be 0.05x cubed over 3 factorial, and so on. And so as you can see, we've got increasing powers of x, and with some coefficient in front, which you can just work out on your calculator. And so I just used an online calculator to express this in full. That is the first 6 terms, and then you would have to evaluate each of those coefficients on your calculator up to 8 significant figures, which is a bit of donkey work, but it's not especially hard, and that should get you the answer to part A. There was then a second part of the question, which I don't think massively relates to the first part. I don't think it's a hence or otherwise question. And the follow-up question was to evaluate this integral 2e to the theta times sine theta d theta between 0.1 and 0.4. Now that certainly looks like an intimidating integral, but we've been told to use the Maclaurin series. And so that massively helps us because, as I said, the Maclaurin series itself is in the formula book. So using this same expression, sorry, PC problem. Using this same expression from the formula book earlier, we can rewrite the integral as, so we're going from 0.1 to 0.4, it's going to be 2 times some terms out of this, and I think what's going to be important is that we need the answer to 3 significant figures. So we need to make sure we include enough terms to get 3 significant figures, and we can think about how that's going to be possible in a moment. Now, the formula book also gives us the Maclaurin series of sine x, which I can just put next to it here. So we can also pop that in, and hopefully you can see where I'm going with this, that this is going to give us simply a polynomial to integrate, so powers of x to integrate, instead of anything complicated with e's and sines. So this is going to be much easier to integrate. I've put in terms of x. The question was in terms of theta, but that doesn't make a difference. Okay, so now we have the question of how many terms do we need to include? Well, we could do this a bit experimentally, but it wants it to 3 significant figures, and we can see that we're going to be substituting in some values with 1 decimal place. So that probably means we want up to the cubed term. So we can now start expanding these brackets to find all of the terms that would include up to and including x cubed. So I'll take the 2 out to the front of an integral. You're allowed to do that. So we've got 1 times x, which is x, and then we've got a term that would be 1 times minus x cubed over 3 factorial. Okay, so that's an x cubed term. Then going to multiplying this out, we get x times x, which is x squared. And then that times this would give us an x to the power of 4, which I suspect we don't need, so I'm not going to include it. And then finally, we're going to have this times this, which gets us x cubed over 2 factorial. And I'm going to do all of that dx. Okay, so at this point, this is easy to do. All we need to do is simplify this because we've got 2x cubed terms. Then, as I said, we've got some powers of x to integrate. You probably know how to do that. And then substitute in your values. And that should get you to 0.192. Now, sorry I haven't had enough time to go through the individual steps, but I think you can do the integration part yourself. And I've hopefully explained the main parts. The key to part 2 is applying the Maclaurin series and then applying the expansion to get the powers of x that you need, and then simply doing the integration. As I say, if you do have any more questions, drop them in the comments. Thanks.